Hey guys, Mr. Backerberg here. In this video, we're going to look at verifying a sinusoid algebraically. So in this example, we're going to look at expressing the function f of x equals 2 times the sine of x plus 5 times the cosine of x as a sinusoid in the form f of x equals a times the sine of bx plus c. And I'm actually going to start by focusing on this a times the sine of bx plus c, because we have identities that we can use now that we know things about our sine sum formulas. So what we've got in here is we're going to take a times, and then I'm going to use my sine sum formula to rewrite this sine of bx plus c. So we do the sine of bx times the cosine of c plus the cosine of bx times the sine of c. Now what I'm going to do is distribute this a in, and then I'm actually going to rearrange things a little bit. So we would have a times the sine of bx times the cosine of c plus a times the cosine of bx times the sine of c. Now this cosine of c right here and the sine of c on the back end, because we're evaluating just a specific number, c, that's actually just going to give us a constant. So I'm going to move that into the front so that we have our variable on the end. So we're going to have a times the cosine of c times the sine of bx. And then I'm going to do the same thing on the back end here, moving that sine of c towards the front. So it's going to be a times the sine of c times the cosine of bx. Now if we compare that to what we've got, so I'm going to set it equal to the 2 sine of x plus the 5 cosine of x that we were starting with at the very beginning. And I actually want to compare some of the coefficients. So let's first look at this piece where we've got the 2 sine of x. Well, where we've got our sine with the variable, that's in the very front here with the a cosine of c and the sine of bx. So I want to compare this coefficient, a times the cosine of c, to the coefficient right here. So a times the cosine of c is going to have to equal 2. And if I do similar things with what's on the back end, the coefficient in front of my cosine is a times the sine of c, and that's going to have to equal the coefficient in front of my cosine of x on the end, so that's going to equal 5. Now one other thing that we should notice in here, as we look at this b value, this number in front of our x, if we check both pieces on the right hand side, the number in front of that x with the sine is a 1, and the number in front of the x with the cosine is a 1. So we know that our b value is 1. I'm going to take these two bits of information that we just came up with, and we're going to work on finding our a value, and we're actually going to do some Pythagorean theorem type of ideas. So what I can do is I can take that a times the cosine of c squared plus a times the sine of c squared. And that stuff is going to have to equal the 2 squared plus the 5 squared. Now I can actually algebraically play around with what's happening on the left-hand side a little bit. If I were to square each one of these, this would be a squared times the cosine squared of c plus a squared times the sine squared of c, and that's going to equal 29. Now on the left-hand side, I can actually factor a squared out, and then we'll get the cosine squared of c plus the sine squared of c. And we should recognize this as one of our Pythagorean identities. Cosine squared plus sine squared is just 1. So we're going to get a squared equals 29, and then we have to square root both sides, so we get an a value of plus or minus the square root of 29. Now for the sake of this example, we're going to assume that we've got a positive length in here, so we're going to use the positive root 29. So now what I'm going to look at up here with this equation right here, where we've got a times the cosine of c equals 2, we just found our a value to be the square root of 29. So I could really rewrite that as the square root of 29 times the cosine of c equals 2. But then I'm going to divide that square root of 29 over to the other side. And that tells me that the cosine of angle c is 2 over root 29. And I can do similar things with this a times the sine of c equals 5. I can fill in that root 29 as my a value times the sine of c equals 5. Divide that square root of 29 over to the other side, so I get the sine of c equals 5 over the square root of 29. Now, to solve for c, it really doesn't matter which one of these we use. If we use this cosine equation, then this would say c equals the inverse cosine of 2 over root 29. Or if we use this sine equation, this would say c equals the inverse sine of 5 over the square root of 29. Like I said, it doesn't matter which one of those we use. But now we've got all of the pieces that we need to start building our sinusoid. So we've got f of x equals, we found that a value earlier to be the square root of 29 times the sine of, we said that our b value was going to be 1, so this is going to be x plus. Now we said that there was two different c values that we could use. We could either use the inverse cosine of 2 over the square root of 29, or if we wanted to, we also had that inverse sine of 5 over root 29, so we can safely use either one of those as our c value in our sinusoid. So this is our function. This is that 2 sine of x plus 5 cosine of x re-expressed as a sinusoid using what we knew about our sine sum formulas. That's going to be it for this video. Thanks for watching.